Como is a Komodo dragon and a movie director who wants to win the Oscar for Best Film. This time, he is trying to film a documentary for children about the history of electricity. Como wants to make the documentary as realistic as possible, so he asked Sebastian to dress up as Benjamin Franklin for the film. He also wants to learn more about electricity before he starts filming so that he can teach others about how electricity works, and his documentary could win the Oscar for Best Film. That's when he called Gallo-Einstein to learn more. Gallo-Einstein was in his lab inventing a solar-powered drone that could be used to deliver BRAINopolis science kits when he got the call from Como. He was happy to hear from Como and wanted to help him learn more about electricity. The study of electricity began in the 1740s, after Benjamin Franklin proved that lightning is a flow of electricity in nature. Benjamin Franklin did his famous kite experiment in 1752, which proved that electricity and lightning are the same thing. In the late 1800s, Thomas Edison and his team came up with over 1,000 different inventions, but his most famous invention is the incandescent light bulb. Thomas Edison wanted to use the light bulb to bring light into homes and factories. Up until then, people only had candles or oil lamps to use for light. Most light bulbs use current electricity to produce light by using some kind of a cable connection. There are, however, two different types of electricity: static and current. One way to experience static electricity is by rubbing a balloon on your hair. Your hair will stick up due to the static electricity. On the other hand, current electricity is when you plug your electric toys into a wall socket. But before we get further into the differences between static and current electricity, let's first talk about atoms. Everything in the world is made of little particles called atoms, and atoms are made of even tinier particles called electrons. Electrons are the particles that produce electricity in an atom. At the center of an atom is the nucleus. Electrons rotate around the nucleus of an atom. When objects rub against each other, the electrons can jump from one atom to another, and this creates an electric spark. That is what we know of as static electricity. When we rub a balloon on our hair, the electrons from the balloon jump between the different atoms in the balloon and the atoms that are touching our hair, and we create sparks of static electricity. Current electricity needs a constant flow of electrons. Think about your electric toys, most of which need a cable to work. The cable creates a circuit that connects the toy to an outlet or power source. This gives the toy the constant flow of electrons they need to work. Static electricity only needs one electron to jump from one atom to another one. On the other hand, current electricity needs a constant flow of many electrons, which is why we use wires to connect electrical devices to power sources. For example, think about your computer. Your computer needs to be plugged into the wall using a wire to stay turned on. That's because your computer uses current electricity. Another difference between static and current electricity is that static electricity does not need to use a circuit, but current electricity does need a closed circuit to work. Since there are a lot of differences between static and current electricity, it makes sense that you would find each type of electricity in different places. For example, one place you would find static electricity is in a lightning bolt, and somewhere where you could find current electricity is in a battery. Electricians use special symbols to represent electric parts in their diagrams of circuits. A battery is represented by 4 lines. Wires are simple lines, and the light bulb symbol looks like 2 circles and a line. If an electrician wants to draw a simple closed circuit that uses a light bulb, wires, and a battery, he would use 3 symbols, one for the battery, one for the wires, and one for the light bulb. Galileienstein's explanation of electricity was very helpful for Como's documentary. However, he did not end up winning the Oscar for Best Documentary for Children because the judges thought there weren't enough explosions in the movie. But the good news for Como is that he took some great pictures of Sebastian dressed up as Benjamin Franklin trying to recreate his kite experiment. He hopes he can use these photos as Halloween cards for his friends. Look for the experiment on our website, www.brainopolis.org. And remember, the more you play, the more you learn.